So I'll get started if you all want to listen. If you don't, just keep quiet and do whatever you want to do. This thing will press that.
Yeah.
It's cool.
Something like that. You have to turn it on first.
Oh. That's a bit too sophisticated.
Design flaw.
Yay!
Okay.
Like
So tonight's agenda, what have we got? News. There's not much news, but we'll cover that in a sec. Hardware news, just bits and blobs of hardware that might be of use to people. PyCon AU. I'm going to talk about FuPy, and in fact, Nick's going to talk a bit more about FuPy.
Yep.
FuPy is an effort to get MicroPython running on FPGAs. It's kind of interesting to some of it. I'll talk about Tomu briefly, and I think Sean and Oliver, you guys are going to talk briefly about the cases.
Yeah, sure.
Cool. So we built a couple of cases for PyCon. This is one of the projects.
Whoa.
Correct thing to say. Yep. I wouldn't mind an ooh or an ah, it'd be nice. Thank you. Anyway, the case here that holds these together was put together in a very short amount of time, but it's a really nice case study on tissue on how 3D printing can work for us. And Peter's going to finish off with some LoRa stuff.
Well, hopefully. I might start my week there.
Well, you got at least 5
Well, that's
something. Okay, so news. Since our last meeting, Nick, Damien, and I presented it. So
We can edit that bit out, right?
Yeah. So the impact presentation was. Go?
Yeah, dead.
The impact presentation was good. The Python user group's 60 or 70 people typically. So it's a largish group. And Damien kicked it off with like, here's how MicroPython works and what it is, and all the good stuff that he does. For those of you who don't know, Damien's the creator of MicroPython, Melbourne guy, like us. And then Nick and I talked about some projects we built. And, Nick talked about rockets, making rockets. And Andy, you featured in those too. You got covered in water.
Yeah,
A couple of photos. Yeah, so water rockets, where they're getting live telemetry data. At some point, we probably should do that presentation here as well.
Yeah.
What percent when we actually just turn it off?
Or you could do that too. Yeah, wait till the weather gets a bit warmer, perhaps.
Yeah.
Late October is the plan. Yep.
Okay, cool. That's news. We've got a recording for that. I'll put that online as soon as I process the video and stitch together the interrupted videos that we always seem to have. I also mentioned PET 505, which has been around for a little while, but it's talking about none-aware operators, I think is what they call it, which is where you have question marks. So you use the question marks to say, hey, if this object's none, then I want to do something, right? You can just shove a question mark in the middle of your statements to shortcut that. It's got some nice benefits. There's a lot of languages that have this, but at PyCon it was really controversial. One guy was just dead set against it. He gave a lightning talk about how it was just made the language very obscure. So go check it out. It's also one of the ones that contributed to Guido's departure. It was quite a controversial one, so it's worth having a read. What we got here? Hardware news. Seon. I'm sure I'm saying that wrong.
Good enough.
Okay.
Seon,
sorry. Seon. So Seon's here tonight. He announced that he's got his Reflow Master. So that's been put on Tindy, 3 weeks ago or something like that?
Yeah, I saw my first 3 in an hour.
Yeah,
and
yeah.
I'm trying to make more stock.
Right.
I've got more. I've got about another 30. In the next 2 weeks will come out.
Right. So for those of you who like playing with electronics, this is like using a fancy-ish toaster oven.
$30 Kmart toaster oven.
There you go.
Plug this into it with an SSR and you get perfect reflowing of surface mount boards every time. Yeah.
Cheap alternative, but really good alternative for those of you who are doing that kind of stuff by hand.
Don't cook your food in it.
Well, we have a toaster oven here, so it'd be good to fit one of your units.
Do you want to come quickly?
To permanently show it off.
That one. Yeah. Okay.
Yeah. Feel free to.
Yeah.
I've got some photos.
Sorry. Yeah. Sure. Okay.
Please.
So it's running a SAMD 21, which is a Cortex M0 microcontroller, and you plug your K-type thermocouple into it, which lets you read your temperature, and you drill a hole in the back of the oven and shove that in the middle. You connect your relay through just an SSR. $20 here or $3 from China. I don't know if I trust the $3 ones, but because you're playing with mains. And you can also control a fan. So what I've done is I've cut a hole in the back of my toaster oven and printed just with PETG, just like a little tube, and have the fan sitting at the back. And so at the end of the reflow, just because at the end of a reflow it needs to go through a cool down, and toaster ovens don't change their temperature fast enough to be able to cool down quick enough. So I kick the fan in and it starts cooling it down faster, and it beeps, tells you when the fan's starting, and then beep 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 tells you when to open the oven door. You open the door, and and basically pull your boards out. I reflow up to like 5 or 6 boards at a time inside it, and it's really good. I used to do it by, I was saying before, I used to do it by eye, so I'd have to put stuff in the oven with a torch, and I'd be watching it, and then I'd watch it when it reflowed, and I'd count to 30, and then I'd open the door and pull it out. It's the least scientific way of reflowing ever. But with this, I do 10, 20 boards a day,
And
just burn through.
Punchline, how much?
Oh, so it's $89 US on Tindy with free shipping. Obviously, I don't have to worry about shipping. If it's here, I can organise something with that. I can organise discount codes for that. But it's also completely open source software and hardware. So if you want to download the files, if you want to build your own, if you want to modify it, whatever you want to do, it's all in C. Sorry.
For now.
But I'm desperately trying to learn how to code in MicroPython, so you never know in the future. Interestingly, I actually started developing this on an ESP32, but I had a lot of trouble in C land with PWM and stuff, and couldn't do half the stuff I wanted to do, and I abandoned it, unfortunately, because the ESP32...
PWM with the ESP32.
The ESP32 was like dramatically faster, and I deliberately didn't build a Wi-Fi enabled reflow controller. They already exist out there. My theory is you don't walk away from your oven when you're reflowing. You don't need to be doing it on your phone because it's a very short cycle, and if you're not watching the oven, it's like walking away from a laser cutter when you're cutting.
Yeah.
Right? You don't do that.
And
So
ovens typically how much they cost? Just so the package.
33 or 39. I think I've got mine for $30 at Kmart. So the thing to be aware of with an oven is you want it to be small and powerful. You don't want a big oven because they take too long to lift heat. So that's an 18 litre oven, so anywhere between 16 and 18 litres and 1300 watts or above. But seriously, Kmart, $30. Perfect. I've reflowed hundreds and hundreds of boards with it. So.
Awesome stuff.
Thanks, Justin. For people who do feel a bit nervous about mains, you get something like the son off, and that's where the Wi-Fi would come in handy because then basically you just ESP
Absolutely.
to son off, and then you're not playing 240
Yes, for sure. I mean, technically you could. I mean, I'm just using an open SSR, but you can get all sorts of devices where you just plug your power cable into it. Like you don't even have to touch mains. In my case, I wanted it all inside the oven, so I took an angle right into the oven.
Yeah.
That's interesting. So, but I've got lots of other ESP32 and 8266 stuff that I'm working on as well, and I'm going to do MicroPython.
So here's an idea.
For those.
So I've got a sign-off unit at home. You plug it into the wall.
Yep.
And you plug your plug into that.
Yep.
It's got an ESP8266. It's got Wi-Fi on it.
Yep.
So if you had an ESP32 as your controller board, you could turn it on and off at the right times. That'd be kind of cool.
Yeah.
Just like
Open source.
Yeah, for sure.
Add whatever you want to
Yeah,
it. You can
absolutely.
contribute or run with it yourself. I've got a lot of people asking for features for like VGA, reballing, and all sorts of stuff, and I'm saying it's open source. If you need that feature,
do it.
I don't do VGA, so I don't understand.
And for people who would like to do that but don't know how to get into that, so you're in a hacker space, and so there's electronics workstations here. There's people who run electronics classes, and we've sent boards off locally and that sort of thing. So if you actually would like to but don't know how, come along and come here and sort it out.
Electronics is great fun. And surface mount electronics is the most fun.
And while we're plugging, I mean, you obviously run the YouTube channel for. No, I wasn't trying to plug your stuff, but like you might as well.
I've got a YouTube channel called Unexpected Maker that I basically document my journey of blowing things up or doing things at work.
I've subscribed already.
Thank you. And so I basically build hardware, open source hardware for a living, which does not pay the bills at all at the moment. But I think it's really important to give back. So I try to make, not all of my stuff, but I try to make at least 90% of everything I make, either code or hardware-wise, open source, and give back to because I learned from people sharing open source as well. That's how I got started, and so I want to give back as well. I'm interested to see if I can convert any of my stuff over to MicroPython. I'll also include that on GitHub as well, and would love help from people who know more about MicroPython than I do.
That's a D21.
Sorry?
That's a D21.
SAM-D21.
Yeah, SAM-D21.
You'll be able to run CircuitPython.
Yes,
out of the box.
Yes, that can run CircuitPython out of the box. That actually pretty much emulates the Feather M0, just because I'm using their bootloader, because it's a much better bootloader than the standard Arduino one. That's why that new Microsoft file format might be
Cool.
cool with MicroPython, because you can just swap them out.
Cool. Thanks.
Thank you. Thanks. Bye, everyone.
There's a few other bits and blobs of hardware that's useful. M5 Stack, TTGo, and SP Drive. I've got a few more photos. So M5 Stack, you're off and running, doing more things. Some of you would have seen the other camera module of theirs. If not, I'll show it around later. This one comes in a case, and it's got PS RAM, and it's got a whole bunch of other little sensors and stuff. They're about $20 odd. The only thing to beware of here is that extended use of the camera module is not recommended due to its tendency to overheat. So don't know about these heating problems. Filming in short bursts seems like it's a warning sign to me, but their hardware's been pretty good in the past. So let's see what it's like.
On your camera.
There's also this Bala, which is just too cute that I had to buy it. It's coming across. They've got some encoders and some wheels. It's designed to be a self-balancing sort of unit. It's pretty cute. I'll bring it in hopefully next meetup. TTGo have released a small little ESP32 module. This one's based on the Pico D4, which is Espresso's tiny little system in the package, which has all the passives inside that little chip there. These room chips are not, is anyone any handy? They're not particularly big anyhow. Sean's got one here.
Yeah.
There you go. Right, so it's actually a lot smaller. So if you're looking, if size is a constraint, then
Is it the same though? The same functionality?
it's the same. So the Pico D4 is basically this drop-in for the SP32. It's as in the big daddy of this thing.
Yeah.
Basically the same functionality. Yeah.
You're not missing out on anything at all.
Nope. Same die. The only difference is that inside this little package here, you've got a whole bunch of there's flash, there's blah blah blah. All of that they've shoved inside the package, and this is a little bit bigger than the base ESP32 module. So they've grown this a little bit, but everything's inside it.
There might be a slight performance here because it uses a QSPI flashing 2-bit mode.
Yeah. Yes. Yeah.
But otherwise it's the same.
There's plenty of other chips. Yeah, you're right. Absolutely right.
Because there's a painful to get on the breadboard. Like that's the narrowest you can make.
Yep.
Yeah. Okay. Awesome.
That was, oh no, so SPI drive is another thing I've bought. This has got nothing to do with MicroPython, but if you're dealing with SPI, this is a device that was on Crowd Supply that I've picked one up. You can plug it into a PC. They give you a library to drive SPI commands, and you can watch it as it goes through. It's helpful for debugging SPI. Maybe you've used it guys.
We should talk.
Yeah. Right, so PyCon. It's a big deal. PyCon's the big national conference for Python. The structure is that you have one day of mini-confs. This is on the Friday. On that day they have 4 separate tracks, so they have a room dedicated to each of the tracks. One of them was the IoT track, which I helped organise this year with Lachlan Blackhall and Mike Leonard. About half of those talks were MicroPython-ish talks. The other tracks were all interesting as well, but I didn't get to see any of them, so to speak. Then they've got the 2 main conference days, so it's just regular Python topics for 2 days. They also have lightning talks at the end of each day, of which Andrew was good enough to present. I've got yours. Why not? And then there's 2 sprint days, which I didn't get to stay. I think, Nick, did you stay?
No, I came back for Compose.
So the sprint days are just where people gather to hack on their favourite project, which is really the Python. People self-organise into groups and develop stuff. Really good conference. There's about 740 attendees, something like that. It's kind of large. About 90 talks. Each talk they have a 30-minute slot, so you get the impression there's quite a lot of details communicated here. What else we got? It's really, they make a big deal about making it inclusive and safe. And one of the great things is you do get a lot of people from creative aspects. You get a lot more females, I'd say, than most conferences you go to. And so you get a bit more diversity in the audience, which is a really good thing that they do promote that. This was also interesting because this is one of the first conferences they'd organised such that there was always at least one non-male person speaking the whole way through the conference, which was really cool. The videography was incredible. I think the record was like within an hour 12 or something of the presentation being finished. It was already online. So all of the videos are now online. You can go look them up. They're linked into the schedule as well, so you can see an overview of all the talks. and go watch any of the videos.
By the time my plane had landed in Melbourne Sunday night, everything was live. Every single talk was
It was.
live.
It's amazing.
From the 4 to 3 days worth.
They've got it down.
And their AV gear is built on Python.
So again?
The AV gear is built on Python.
It is, yeah. Tim's pushed that. So yeah. Yeah. The lightning talks are a different format. They've got like was it an hour? The lightning talks. There's an hour block, and there's 5-minute talks. So people come up and give a really short, but punchy kind of talk. It's a good format. And also during the talk was really cool. Twitter was used heavily. Fantastic. Pizza. Did that interrupt? No.
You got a notification for that.
Yeah, cool. So between Twitter and Slack, all sorts of things happened while the conference was going on. So I got pinged a few times on Slack, and we had impromptu meetings like after after the current talk that we were sitting in, we'd go meet people because they'd had questions or wanted to discuss things. So that was really cool. And the venue was fantastic. It's the ICC, the International Conference Centre in Sydney. It'll be there again next year because they do it in 2-year batches. It's really hard to speak poorly of it. It was just amazing. Like as a speaker, it was great. In the audience, it was great. It was just all really well run. It was just like, and the food was good as well. So they had morning tea, they had afternoon tea, and they had lunch, and there was never any shortage of food. It was really in good quality. I picked together all the talks that referenced MicroPython. If I've missed one, please tell me.
I'm not going to remember off the top of my head.
Yeah, sure.
So
I spoke about async IO. Damien talked about making MicroPython really efficient, and to deliver the punchline, he went from flickering an LED on and off at 50 hertz, 50 hertz to megahertz. So he went through 7 different stages of optimization. He said that most normal people should stop at about 3. So he went to some extraordinary lengths to make it go quick. Stacey Morse talked about having like some neopixels and using that to light her macro photography stuff. Really cool talk. You'll have to, where are you, Peter? You'll have to watch Brian's talk on LoRaWAN. That was pretty interesting. Tim talked about FuPy, which was actually a hilarious talk. If you've got a spare 4.5 minutes, Tim's lightning talk on FuPy was really good value. Nick talked about his rocket surgery, so even if he doesn't present here at some point, you'll be able to go watch that. And Andrew with the longest title ever. I don't know if you intended that to be read out, but
I didn't intend it, but I half expected it.
Yeah. So how do we embed devices on better with MicroPython and Jupyter? It's really professional use, so good. Pretty pleased. I have lights and live demos. It's got to be a good laugh. And it was honestly,
I passed over on Saturday. I really wanted to do it on Sunday.
Yeah, it was a really good talk. Really good. One thing we haven't talked about here is using Jupyter to play with MicroPython. So Jupyter, for those that haven't used it, is like it's a cell-based environment. You start up a web browser and a web server on your computer, but there's a MicroPython kernel, so you can drive your commands through to a MicroPython device. So you can download them straight away and get feedback within the browser. It's a really convenient way to do it, and I'm sure you're going to show it off later.
Yeah, I'm happy to.
Cool.
Still got the lights.
Sorry?
I've still got the lights.
Oh, fantastic. Yeah. That's what the schedule looks like. Each of these is linked to the summary of the talk and the video. That looks something like that. Excuse the poor model. One of the things that was really cool was the hallway track. So that's what you call it when you meet people out in the hallway of the conferences. So in particular, it was great to have Nick and Damien, myself, Tim, Gus from Expressive. And we were able to talk about a few things like progressing the Bluetooth API, which is definitely coming, and it's definitely coming soon because Damien needs it for the new version of his Pi board. But there's also 3 other people working on it independently, so Damien's been working with them to try to progress that. Right now we have very basic support for ESP32 and the NRF52 to do advertisements, so that's working now. That's going to be expanded. It's kind of difficult to get the right level of abstractions with Bluetooth because it's like a 3,000 page spec and they want to support a number of different layers of that, so it's quite a complex thing. FuPy, FPGAs with MicroPython, we'll talk about that in a sec. And we talked about managing forks as well because there's a whole bunch of people who are forking it, which is great, but we need to make sure we bring things back to mainline. There's a self-organising dinner, which we're running. It's hard to talk when there's the smell of pizza, right? So I'll skip over some of this. I had to talk about the flip-flop operator. It turns out that there's a crazy flip-flop operator in Ruby, and one of the keynote presenters just mentioned this off the cuff and said it's just completely a bad idea to do it. So by the end of that day, which is only a few hours later, maybe it's next day. Anyway, someone had a lightning talk to explain how that operator worked, right? Yeah, same day. And she nicknamed the term flip-floperator instead of flip-flop operator. Yeah. So this became like a running gag for the rest of the day. By the end of the next day, there was 7 libraries. One of them had been pushed to PyPI. Half of them at least had unit tests and were quite serious about it. This is all a terrible idea. Don't do this. Don't even look it up. It's not worth it. But it was really quite funny.
It's so bad they're removing it from Ruby.
Wow.
But we now can duplicate it at least in Python. I'll skip over this because we're running short on time. But if anyone wants to talk about how the submission process works, come talk to me. But in short, if you've got an interest in Python or MicroPython, go present. It's a really good, rewarding thing to do. It's not difficult. It's not so scary. Come talk to me if you're thinking about it. Right, FuPy and Tomu. I'll quickly show Tomu because it's somewhere.
I got one on top of my go box.
You got one on top somewhere? No, I got one here too. Tomu has nothing to do with MicroPython.
Here's one.
But the guy who put it together, his name's Tim Ansell. He's actually given us a bunch of them. I've just left them at home. So I was going to give him out to one, but you'll have to wait till next. You'll have to come back next time and I'll give you a Tomu. That's a Tomu. It's a little microcontroller. Not quite powerful enough for a MicroPython, but it's a little microcontroller that you can shove into your USB port. And from there, it's got capacitive touch sensors on the outside, so you can press 2 buttons. It's got 2 little LEDs. That's about all it's got. But you can't access it from USB. You can program it via the USB port. It's a very cute little thing. Now, Tim did this as an experiment to see, at least partially, if it was possible to have, this is hobbyist grade stuff. Anyone here could put one of these things together with a steady enough hand. Don't drink coffee and you'll be okay.
Or reflow oven, to be honest.
Sorry?
Or a reflow oven.
Or reflow oven, just saying. You know? There's also a little case that he's got made for them as well.
Oh, wow.
USB plug.
Sorry?
The case turns it into the USB
The case turns into a USB plug. And while we were at the conference, someone actually took one of these, and when they were doing the videography stuff, they programmed it up so the light would flash red when the camera was active. So that was a cute little use of it, right? We want to give you these away so you get a feel for it, but they're also looking at doing different processes in that form factor, and the next processors will definitely be able to run MicroPython. So I'll leave that out here so you can all play with it and jam it into your USB ports. Can you quickly talk about FuPy?
Well, very, very rapidly talk about FuPy. FuPy is MicroPython ported to run on FPGAs, and FPGA is like a reconfigurable microprocessor. So it's a chip that has lots of gates, and you can rearrange the gates inside it in software, or as we call it, gateware, to make it into all sorts of different things, including CPUs on a big enough FPGA. So you can say, well, define me this kind of CPU and this kind of I/O. So you can define multiple buses and multiple peripheral circuits and decide how many PWM channels you want and program those in. It's really exciting to work with. What you normally do is you define a thing called a soft core, which is a CPU core that can run code within the FPGA. And there's a few of them. There's LM32, RISC-V, etc. We've got a port of MicroPython to the LM32 running on a particular kind of board called an RTX. And that's enough to run MicroPython and flash an LED, which is, always that moment of enlightenment. It's great to see.
Just to say, in terms of engineering effort, using an FPGA to simulate a soft core to run MicroPython to flash an LED is just
it's a whole nother level of indirection. Yeah. But it's very exciting to do that, and the aim there with that project is to continue to support more and more hardware so that we can support all the things the RTX is capable of doing. And that's pretty exciting. I've been fiddling with it a little bit over the last few days and got as far as flashing multiple LEDs. So that's exciting.
Are you actually talking about using MicroPython to program the gates on the FPGA?
So first, there's a thing called LiteX that is using regular Python to compile the gate description.
Okay.
So
Instead
that
of like
you don't need to write
VHDL.
It's set up.
Yeah.
Really?
instead of VHDL.
No, but that's
Verilog.
not from MicroPython. That's
No,
that's,
I understand that. Right.
Now, that's another project, but
Yeah.
then running on that soft core, you have MicroPython, and it gets a thing called a CSR from the compilation process from LiteX,
Okay.
which describes what hardware has been compiled or what gateware has been compiled.
Right, okay.
And then MicroPython has access to that description, so it can address that custom hardware directly.
Okay.
So you can go, I'm going to make 5 SPI buses, and MicroPython will be able to see that there are now 5 SPI buses. So that's pretty exciting. I mean, for this kind of semi-custom thing that people like to do.
Yeah. It's also got some other uses too. So it's not just a sort of, let's build our own little micro on an FPGA. It's also, you can do some things in FPGAs that are really hard to do otherwise. Like you get really like fine timing critical sections. So if you want to do like crypto, or you want to shift around gobs of data, or if you want to have a dozen PWM pins, you can do all that kind of stuff in the FPGA world. And it's a relatively simple thing to expose that through MicroPython. So it is quite an interesting application.
Yeah.
That's the BX. So
Oh, yeah, so
it's one of the
that's-
targets. So.
That's one of the target boards is these teeny tiny little boards, and the other one is the Artix, which is the one I've been playing with.
Yeah, the Artix
which
is
is a fair bit bigger, but a very powerful little beast.
One of the nice things is these are about $30,
Yeah.
and the chip that they run on is only about $1. So
So I just bought one of those, and I'm too scared to even plug it in because it's a whole different world.
yeah. FPGAs are a different beast.
Yeah.
I guess we're trying to make it more accessible.
It's awesome.
Yeah.
I don't know much about them, but I know I have had a look as far with LiteX as sort of saying, okay, so I've got all these RGB LEDs. How do I define PWM channels in gateware
Yep.
to control each channel of each LED? How do I then reflect that through into MicroPython? And there's nothing there that's too weird. There's nothing there that's
Okay.
totally beyond human comprehension or anything. So yeah, I think there's a lot of potential with it. Anyway, more news as it becomes available.
Cool. If anyone wants to, I'm sure Nick will want to show his flashing LED.
Oh yeah, have a look at the flashing LEDs.
I think that's all I got for this.
Yeah.
Cool. All right. So we've got a couple of other things to talk about, but why don't we eat first?
I'll just fix that. Sorry, I mentioned space. Did you introduce people to space earlier, or?
Briefly, I've taken a couple of people through, but
Okay, I'll just very briefly.
there's a video on
First
this.
one is, how many people here, this is their first time at the space? So, a few? Okay, well, welcome to the Hackerspace. As you can see, there's a lot of hardware which everyone's studiously staying away from. But no, this place, people come down, sort of by members, for members, and we really like to host things like MicroPython because it's obviously got a very close association with hardware. So basically, people come down on Monday nights, Tuesdays, Wednesdays. We're trying to get Saturdays up, and basically, it's people with no experience. Newcomers are very welcome. Some of the equipment might look a little bit. I know, maybe you might hurt yourself on it, but no, people are very friendly and want to get more people into hardware. So it can be either there's the mill up there. So obviously last weekend people were actually milling out of a solid core of aluminium, a project box for an ESP32. But there's the laser cutters, that new big one is incredibly easy to use. Just throw a DXF file out and cut up to 15mm plywood, so make boxes and things. There's a 3D scanner, there's mills, there's a vacuum former, so you can make cases for stuff. And there's a number of professionals here who've got electronics companies or startups, hardware startups. So eventually your MicroPython device you're going to want to either put in a box or basically make a PCB for the hardware connect up to. So this is why this place exists. To it was Alan Kay said if you're serious about software, you build your own hardware. Anyway, so the website's Hack Melbourne. And I'd like to thank Matt and Nick for putting in so much effort around everything's all the MicroPython stuff here. It's really appreciated. And one way to think about this place is no small group like Arduino or 3D printing that could maybe carry the load of administration and keeping a place like this going. But it's like an umbrella, so all these groups come together, and our common interest is basically to have a tech workshop full of cool stuff where It's all volunteer. It's not commercial. It is run like a business because you obviously got to pay insurance and rent and that stuff. But it's fully volunteer run, and Peter Knight's volunteered some gear, and people come down and keep the gear going. So it's an awesome place. So please come back. And thank you for holding back from the pizza.
Yeah, the hackerspace has been very generous in allowing us to use the space for this night, and so
Goes both ways. There'd be no point being here if you guys didn't turn up.
indeed. All right, cool. That's all I have.
Let's get some pizza and noodles, and then we'll talk a bit more about cases.